Welcome to today's demo from Introspect Technology. Today, we give a brief tutorial on video frames and what they look like when they get transmitted over physical layers such as the MIPI D-PHY physical layer from the MIPI Alliance. And so we start with a theoretical background on image frames and video in general in this slide. Well, basically, the active area of an image that you want to transmit is really in the bold square that I highlight here. And the name of the game in video transmission historically has been to raster through the image one row at a time by sending the pixel data. So there's a period in the raster where you're not really transmitting any data, and that's the blanking period. And there are two kinds of blanking periods. One is, the blanking between frames, and then there is blanking between each row of the image that's being transmitted. And so when it comes to CSI2 transmissions on a D-PHY physical layer, the signal parameters really follow this model. And so if I click on a small animation here to show the next packet, what we're showing here is that as we want to transmit one row of the image at the very beginning, during the blanking period, we are typically in an LP state, in a low power state. We're not running high-speed data at all. And as soon as we want to transmit active pixel data, obviously we want to transmit that as fast as possible. And so we transition to high speed and transmit the pixel data according to the CSI2 protocol. And then once the entire row has been transmitted, we go on and repeat it for the next row. And so if we go to the next row, we have a period of blanking, which is delimited by low power, by being in a low power state, and then the period of actual row transmission. And then we keep going this as well. And so the main concept is that each line of the image is represented by one packet, and then the entire image is really delimited by a frame start packet and a frame end packet that kind of delimit the frame and make sure that a receiver understands that it has received a complete frame. And so we will go ahead now and illustrate this with a live system and see what it really means when it comes to signals as they are viewed on an oscilloscope. And so to do this, we connect the SV3 D-PHY generator shown here to the oscilloscope, and we simply connect one data lane and the clock lane to the oscilloscope because we just want to see the concepts at a high level. So we'll go ahead and look at the software now. And so the Introspect ESP software is the same as before. It loads up by default, generating a video frame, so it's very convenient when it comes to understanding video frames. If I click run on this software now, we'll start to see a video frame on the scope, and I have the scope screen here. And the main concept, like I said, is basically delimiting the frame with a frame start and frame end packet, as well as the active rows themselves. And so if I zoom out, we see the frame start packet, which is a short packet, and then we see a series of long packets here, each one of them representing a line. And so without zooming out too much, I just want to go back to the actual image that I was generating here, and you'll see that it was generating a 480 by 640 image. And so that's a large number of packets that I'll have to zoom into. So instead of doing that, I'll just go ahead in the software and just modify the number of packets that I want to transmit. And I'll go really, really short. So I'll just enter 4 rows here, which means that I want to transmit 4 different lines of the image delimited by the frame start and frame end packet. So if I click run now and look at the scope, we'll see basically that the entire image now is very short and consists of only 4 rows. And so I can zoom out just a little more. And so you can see this is the entire image now that is being transmitted. A short packet specified here that's very, very barely visible at this scale. 4 packets representing the lines, and then a frame end packet. And that's basically what a frame looks like. Just by simply changing a number here, if I go to 2 and click run again, we'll see that basically the image now consists of really only 2 lines. If I zoom in here, that's the entire image. It's obviously a very small image, but it illustrates the concept of a frame start, a frame end, and a series of packets in between representing the rows in the image. And what we've done here, as you can see, with very simple commands, we could really modify entire image parameters, entire video frame parameters, just like I have shown here. So this concludes this part of the demo. It's a very simple illustration of the concepts of frames and packets within the context of CSI2 and DSI even on MIPI D-PHY. Thank you.